Hi, welcome to another edition of the Build Tech Talks. My name is Sjoukje Zaal and I will be your host for this evening. Tonight is going to be a slightly different schedule because we only have one session for you. And this session is going to be the second part of a series about GraphQL. And the first part of the session was presented during the Future Tech event last March. So during Future Tech, Donald Hessing and Arin Roy presented a session which was basically an introduction about GraphQL. And tonight, Arin, Donald, and Arjan van Dijk are going to give a deep dive session which is called Creating a GraphQL Server on .NET. So we are going to focus on a very interesting topic tonight, which you should definitely check out if you're interested in microservices development. So if you have any questions during this session, please ask them in the chat and I will pass them on to the speakers at the end of the presentation. And if you're interested in part 1 of this series, you can look at our YouTube channel because it's uploaded there as well. So without further ado, let's introduce our speakers. Hi, welcome Donald, Arin, Arjan. Great that you are here. So tonight is going to be a deep dive session about GraphQL. Can you please give a brief introduction what the session is about?
So shall I go first? Thanks, Sjoukje, for the warm welcome introduction. So GraphQL, what we are going to talk about today is everything building a single API endpoint towards a set of, let's say, microservices. And the power and the capabilities that, let's say, this single endpoints gives towards clients is something that we're going to address. And to give you a little bit of insights already on the session, the number of microservices that you typically have in an architecture quickly gets quite a number. And for clients to connect to all these microservices can become quite a challenge. And GraphQL can give you the single endpoint to query towards these microservices, and very important to fetch the data that the client needs.
Yeah, and also fast, right?
Yeah, that's what we need these days. In let's say if you're into e-commerce or any public-facing website, then response times are important. And what GraphQL allows you to do is to query for the data that you need. And obviously by that, you lower the total footprint for the client to fetch that data.
Yeah, very interesting and very needed, just like you said. So how does this session relate to the first part?
So what we will do is, for those who are new to GraphQL, we will shorten the introduction that we covered in Future Tech in probably around 15 minutes. And then we're going into a deep dive with Arin and Arjan, who prepared full code demos around how to build your GraphQL server with .NET technology. And then Arjan will pick up and will show how to build a client using Razor.
Sounds great. So let's get started. I'm excited. Good luck.
Thank you. So let me get my slides. Yeah. So again, welcome everybody, and welcome to this new build session about creating a GraphQL server on .NET. So in the next 90 minutes or so, we are going to talk all about GraphQL. And we will start with a short introduction as set in, with, let's say, the basic fundamentals of GraphQL. What does it mean? What problems does it solve? And so on. And then we will do all about coding, how to build your GraphQL server and how to build a client that is utilizing this GraphQL endpoint. But let's start with a little bit of context about GraphQL and why it exists. And we're taking a little bit step back in terms of architecture. And what we see as a trend today, it's becoming more and more common to break down monolithic architectures into small APIs that more or less work independently. This provides more flexibility, right, as microservices support an isolated part of the functionality. And an example could be, let's say, an API for products or inventory, or for cart, or maybe even customer pricing. And each of these APIs provides its own data store, but they typically also have business logic, and they come with an API endpoint. And because of this isolation in let's say, microservices architecture, they can be deployed more or less independently and provide agile teams the flexibility to deploy on their own cadence. Now, that's really great from a, let's say, architecture perspective and the flexibility it provides in agile teams. But these microservices architectures also come with a challenge. And the number of microservices quickly becomes a bottleneck for many of clients to query all the data that it needs on their client. And in many cases, that can easily go up to 10 or 15 APIs in order to query the data and render the appropriate screen. And this not only requires a lot of code to build, right? Because for every API, you need to create that integration. But it also gives you the challenges in the area of performance. And specifically in mobile applications that are specific to network utilization and battery life on the device, it is important to have an API that is, only provides you the data that you need to minimize the footprint on network and resources of the battery. And a solution for this problem could be GraphQL, where GraphQL is a query language that provides a single endpoint for clients towards the microservices. And this GraphQL technology allows you or allows the client to query for the data that it needs. And for this, a server runtime is required, which is GraphQL provides. And this server runtime basically processes the requests and forwards the request to the downstream APIs to come back with a single response towards the clients. So in traditional, let's say, REST-based solutions, and this is a bit of an overly simplified e-commerce sample that we give, it requires a lot of APIs. So on this client, we have a profile with a cart and some products on top of it, and maybe you have some ratings. Building this out by using microservices, each with their own REST endpoint, would result in something like the APIs that you have right on the right-hand side. So we will fetch the users and the user profile. We will fetch the cart of the user profile. We will fetch the products. We will fetch the product reviews of the products, and so on and so on. And as in the instruction stated, this, in a real-world example, they can easily go up to 10 to 20 API calls for the client. Now, when it comes to all these API calls, it quickly adds up in terms of resource consumption for mobile clients or to your website. But it also adds up in terms of networking time required to fetch all that data. And a very important statement created by Ilya is that the fastest network request is a request never made. And that was basically the foundation and the principle for Facebook to work on the technology behind GraphQL. Because in 2004, when they launched their mobile application, they really faced a terrible bad performance. And it also, they figured out it was draining their batteries in the mobile application. So they came up with GraphQL, and they are the inventors of GraphQL. So that they have a single API endpoint, which provides you the ability to query for the data that the client needs, minimizing the amount of round trips, but also minimizing the amount of data that actually goes over the wire. So that same example in REST for a GraphQL server implementation with something like this, where the client is still fetching the same data, but is doing that in a single query request. And in this example, the query fetches or queries for the user and the name and the image URL, and on the cart, the number of products, and for the products, the name and the image, and for the reviews, the number of stars in a single request to the GraphQL API. Now, this GraphQL API endpoint then queries the downstream APIs to fetch the individual data from the microservices and returns it in a single response. Now, one problem that typically GraphQL can fix is a concept called of overfetching. So in this example, where we have a GraphQL query for the web client, for example, it fetches the products and the name and the reviews and some properties of the reviews, but also the body and the number of stars. That query and the result might be, best suited for the web client, but might not be appropriate for the mobile client. As the mobile client has a different form factor, the amount of information that you can present on the screen might be different. Now, if you would run that same query for the web on the mobile, you would basically fetch too much data. And that concept is being called overfetching. That same principle, but then the other way around, also called of underfetching, where if a query would consist of not enough information to render the screen, would result in multiple additional calls to fetch the additional data required to render the screen, which is called underfetching. So both overfetching and underfetching is very common principles that you see in a microservices architecture, because one of these APIs are, let's say, either optimized for providing all the information, or it's specifically tailored to a specific client, which then can result in underfetching for clients that require maybe more data. Now, to give you a little bit perspective on why response times and round trips and the amount of data matters, here's some interesting research that has been done. And as for example, Akamai did an interesting research across around 17 retailers. And they found out that conversion rates were the highest for pages that were loaded in less than 2 seconds. And you can see a significantly drop in conversion rates when the page load time increases. Now, that's about, let's say, GraphQL, but there is a whole schema and query system that sits behind it. So let's talk about what sits behind it. GraphQL is all about asking for specific fields in an object from the server. All right, so it's a way to query the data that we want to ensure that we only fetch the data that we really need from a client perspective. So for example, on the left-hand side, we can see a query where we query for a product and name and the price and in stock and the number of stars for a specific review. And on the right-hand side, you can see a response. And we can immediately see that the response kind of mirrors the structure for which we query, right? And this is very essential to GraphQL because you always get back on what you expect and for what you query for, and which the server knows exactly what fields the client is asking for. And the reason why the server knows this is because it's based on what we call a schema. And the schema is published by the server so that the client can let's say, investigate the schema and know how the schema looks like. And based on that schema, it can query the data. What you can also see is that we have fields in the query like name and price, but we also can have, let's say, fields that are of type object. In this case, we have reviews, which is basically an object with fields of number of stars. And what GraphQL allows you to do is traverse all these related objects and their fields, and letting the client fetch lots of these related data in a single request, instead of making several round trips, as you would have in typical REST-based architectures. Then we have the type system, and it's very important to understand that GraphQL is a strongly typed language, and this strongly typed language is enforced by the server runtime. The type system defines the various data types that can be used in GraphQL, and GraphQL comes with a preset defined of types, but you can also compose your own types. GraphQL query is basically about selecting the fields and the objects, and we discussed that in the previous slides. But because the shape of a GraphQL query closely matches the results, you can really predict what comes back as part of your query. So what kinds of objects might return is something you can predict based on your query. What fields are available on those sub-objects is something you can investigate as part of the GraphQL schema. So every GraphQL service defines a set of types, which completely describe the set of possible data that you can query on the service. And then when the query comes in, they are validated and executed against that schema. Hence why we have this type safety. So you can only request for the information that is exposed by the schema. You can query for less information, right? Because that is, let's say, overfetching and underfetching the problems. But you can never request for more information that is defined as part of the schema. So let's have a closer look on how the query in the GraphQL API looks like. Over to you, Arin.
Yeah. All right. So we looked at the schema, and so the schema is the contract that a GraphQL server has with its client. And it always exposes the schema towards the client, and the client can always look at the schema. So what I have here is a development IDE where I am connecting to a GraphQL server that I'm running locally. And what we can see here, it exposes a set of schemas and allows us to browse through it. So we can see that I can query for products, and I can immediately see that, okay, products give me back a list of product, and then these are the fields that I can query or I can ask the GraphQL server to return, and the types associated with them. And we can do that for all kinds of queries, and even for related objects, we can even browse through them to see what is happening. And based on this is where we start writing our queries. So if we are using an IDE, we immediately get some intelligence help. So if we start with a query, and then come down here and say space, and then we see that, okay, for when I'm querying, I can query for products like we saw. But we get a squiggle, and we see, so product is of a type object. So we need to select more fields or exact fields that we request from the server. So we go a little deeper. We can go again, and we can say, okay, I want the name and maybe the price of the products that I have in my product database, maybe, and I can fire off my query. And what we get back, like what Donald showed in his presentation, that the result is exactly mimicking what we requested. So from a flexibility perspective, so against the same endpoint, if another client requires something like an additional field of color, we are still communicating with the same endpoint, but we are able to get back a totally different set of data from the service. So that's really the flexibility of working with GraphQL. And typically this is how you could construct your queries. And if you're using an IDE such as this, you can always use the intelligence to help you construct the queries, or even explore the schema to look at it. Yeah, I think we'll see more of this as we go on in the session this evening. Over to you, Donald.
Thank you, Arin. And that's not an internet promise. We will get more code when we go into the session, so stay tuned. So a little bit about the GraphQL query. So one really powerful thing that, that the GraphQL gateway allows you to do is stitching multiple downstream APIs. So in this example, on the right-hand side in green, we have a set of microservices that each can expose their own GraphQL API endpoint. Now, what the gateway can do is it can combine all these, let's say, schemas from these microservices and stitch them together in a single schema, so that it hides all the complexity of the downstream APIs and allows the clients to talk to one API endpoint and query for the data that is being exposed in a combination of the downstream APIs. And this hiding of complexity is really key for the web clients, because from a client perspective, it doesn't matter, how many downstream microservices sits behind the gateway. They can query for the data, and the gateway will kind of forward the requests to the downstream APIs to get the product information, to get the card information, to get the reviews, fetch it back, and then returns it into a single response. And in this sense, the gateway is kind of the central arbiter, which delegates, validates, and forwards the request to the respective downstream APIs. It also decouples a lot of that integration of the APIs, and this schema stitching can be done on runtime, if you like. So if you would add additional services at startup of the gateway, to which all the downstream APIs is being subscribed to, it will automatically, let's say, fetch the schema and stitch it into one big schema in the gateway at startup. So that really gives you the flexibility in a microservices architecture to get all these microservices stitched into one gateway and provide access to the clients into a single API endpoint. So in order to, let's say, get all this functionality together, right, you need to have something like a server runtime and a gateway. And GraphQL initially was invented by Facebook, which their implementation was based on JavaScript. Now, the power of GraphQL was being picked up by other developers, participating in different platforms, of which .NET and Microsoft is not just alone. So there are several implementations on the Microsoft platform, and we will talk about the Chili Cream platform. And the Chili Cream platform comes with three parts, and one is the server runtime, right, which allows you to create this GraphQL server, which allows you to create a gateway, and basically creates this additional layer on top of your microservices to build the schema, to execute queries, and to forward a request to the downstream APIs. Then we have the client, which is called Strawberry Shake in the Chili Cream platform, which is more or less a code generation tool, which, based on the provided schema from the server, can generate a .NET client for you, which includes all the types and the mapping of the GraphQL types towards the .NET types to simplify basically the interaction between the client and the server. And then lastly, we have Banana Cake Pop, which is like an IDA to explore the schemas on the server, to do some queries against it, and to do some performance insights of the GraphQL server. So it's just really a tool to play and to connect to any server which is compatible with GraphQL implementation, and to query, explore the schema, and so on. So now we're going into the deep dive coding part, where Arin will show you how a GraphQL implementation in .NET looks like.
Thank you, Donald. So, code time. We are going to build an e-commerce background first, and then extend it with a front end. And at the end of this session, we aim to have a complete working e-commerce solution, sort of. So what we have is the story we built today is more like we are building on top of an existing platform where we had our REST APIs working for our current application. So we had a product API, we have an order, and one for inventory, a minimalistic setup as it can be. So looking at the structures, typical endpoints as we can think of. So from a product perspective, we have one for a list of products, something to get back like the top products, or one to even get specific products. And yeah, if we try them out, yeah, all quite known response types and how we are used to working. Same for orders. We could say, okay, give me back all my orders, and we get back a list of orders that people have made. Yeah. And what you're going to try now, what you're going to do now is transform all of these REST endpoints into GraphQL, and then eventually bring them together into one gateway, then that what the client can consume. So just a quick look at what I have in the backend. I have a set of databases. I have an inventory database, orders, and products with simple tables. Products just has a list of 3 products. I have some inventory per product, and I have a list of orders, and a certain Sherlock Holmes seems to order a lot from my store. So that's our data store. And all right. So we have the product API so to call, and we have a controller for it, typical controller with get products with an action for get top products and a specific product by ID. I'm using EF Core for talking to the database, so I have my DB context in here, and I have my product model that defines my product structure. So we go on to convert this into a GraphQL server. So let's get on with it. I will use the integrated terminal to work with this now. So I go into my product API. I'm going to do some copy paste to do some stuff or save some time. So what we do first is we add the package HotChocolate ASP.NET Core. So that's the HotChocolate NuGet package that allows us to, let's say, convert or build our API into a GraphQL server. So this is now done. Sorry, I had something running. Yep. And what we go on to do now is, let's say we create a folder called GraphQL, then we create another called schema types. So what are we doing? So we looked at the types, the types when we saw how GraphQL is structured. So everything is either is some sort of a GraphQL type. So it can be a type of an object or one of the primitive integer, string, and others. So in our case, our model needs to be converted into a GraphQL type. So what we go on to do here is we create a product type class. I'm going to do this. So we already have our hot chocolate package installed, which allows us to do this. And what we say is that this is so our product type is an object type deriving from our product model. So what it is allowed. So we have our business objects, but what we are trying to do is we are defining our GraphQL objects based on our business model. And within this, so we configure our object type with an override, and we have our type descriptor. And within the type descriptor, we can something like this. Maybe I will close this for a better view. So what we did, so we have our object descriptor, and our object descriptor can define a field. And what we see, if we quickly take a look at our product, we see the fields that we have: ID, SKU, name, description, color, price, image. What we are trying to do is we are trying to, with the object descriptor, describing those fields. We are saying, giving it a type. So this is mapping the .NET CLR type to the GraphQL types that are defined by HotChocolate. So we see that we have a specific non-null type, and we have a ID type for ID-based fields. But for string, we see there is a string type. For something like price, which was a double, we have a float type. So what we did here is told the parser that these fields from my POCO should map to these types in my GraphQL setup. So once we do this, then GraphQL knows, okay, this is, it knows how to build the schema for products. For example, it knows that these are the types it should use. But it is not complete, because we still don't have a way to, let's say, query this data. So how do we query data? So what we do is we create, always happens with me somehow. It's got created inside this, which was not right. So this is wrong page. So we create a query class, and within the query is our entry point into the data. So what we do typically in a controller in our REST endpoints is what we do in our query. So in our query, we define what are the operations that should be exposed by our GraphQL server. So we do some resolutions. Okay, all errors gone. So what we are doing here is what it allows us to do. If you look at the controller, once again, we had 3 actions there. So we had get products, get top products, and get product. But GraphQL gives us, again, when we build a GraphQL for a REST API, we are again free to choose what operations we want to, let's say, include there. So in this case, I chose to leave out get top products because maybe my client doesn't need it from a GraphQL standpoint. So we just need a list of products, and we need a way to get a product by the ID that's supplied to it. What we see here in the parameters is this service attribute. This is something from HotChocolate, and HotChocolate in this case handles the dependency injection in the context of this call. So we don't have to take care of the dependency injection. HotChocolate is doing that for us at this service context. Yeah, so the rest of it is pretty straightforward. We use the DB context products, and we get back the list. And for this, we use this. But again, we have a query. But of course, for GraphQL to work, we also need to define types for the query. So the same way as we did for products, we have to do the same thing. And this time, we are defining the type for query. And the rest of it is pretty much the same what we have seen. We have the override of configure. We have the object descriptor. So query is a special root object, root in the query structure in GraphQL in the schema definition language. But in principle, it is also an object. So it can be defined in the same way as deriving from object type with a root type, and then we give it a name. We say the fields. In this case, you see our field is the function that we have, and we say the type is the return type that we are expecting. And in this case, get products give us back a list of products. So we have list type of product type. So it's these are again all referring to the types, and this product type is actually what we defined here. So we are doing all of this in the context of the GraphQL types. Once we have this ready, so we have our query, and now we have to let's say wire up our GraphQL server for it to work. And what do? We go to startup.cs, and we go services dot add GraphQL server. That already does it, and then we need to say, okay, what is the query type that the GraphQL server should expose to the clients? Okay, so we did GraphQL server, and the query type is the query type we just defined. There's one more thing. We need to define the endpoint mappings. So we say endpoints dot GraphQL. There's a nice little extension method that HotChocolate provides. So we can just say map GraphQL, and in here we have services, add GraphQL server, and this. So say save. This is not saved. All right. So we already did everything that was needed to convert this product API into a GraphQL service of its own. So what do? We do .NET run. Okay, my service is running at localhost 5011. I can go here, close this in, and I say, so our endpoint is always /GraphQL, and we refresh the server, and if we look at the schema, we see we have product and we have products, and this is typically what we defined as part of our query. We said we have two operations in our query. They were get products, and these are now mapped to products and product. And like product accepts a parameter. So if we see here in the definition, we will see the product gets an argument called ID, and it is of value integer type. And we can write now a similar query that we had seen. So we can do the name, we can do the price, we can do the color, yeah, maybe a size, whatever. And we execute this, and we have our product GraphQL API giving us back the product data. So just a few files, definition of some types, mapping them to the right GraphQL types in here, and we are ready to go with our GraphQL server. So we are already querying, let's say, the first server we have. Something to note here is you have also a lot of flexibility in naming. So if your business object is product, and let's say you want to call it something else in the scope of your GraphQL endpoint, you could definitely have a different name. GraphQL sort of HotChocolate tries to compile all of these names into smaller or camel cases. But in this case, because this is all capital, it sort of struggles. So you can then also have control to, at a field level, say, okay, I want this to be named as SKU. And then if we look at what we see here in the schema, that is exactly what we have. So we also have the flexibility to let's say define our server the way we want it to be. But that's query, and an API for querying data is only as good. But of course, when we are building applications, we also want to write back data, and that's equally important. So for similar to queries in GraphQL terminology, we have what we called mutations, and the mutations, as the name implies, is for doing updates or create kind of operations. It would for brevity and to save on time and to show all the interesting stuff, I already have in my order API created a mutation. So now that we have seen a query being created, it should be quite easy to, let's say, get the concept of a mutation. So again, I have my models. I have my order. Close this. I have my order model. I have line items, and every order can have a list of line items. I had similar queries here, but what I have here is also a mutation. And what the mutation is doing is, this is for a create order, and what it expects is a object of type create order input. It has the context, of course, and then it maps it to a object. So based on the incoming order object, it maps it here. Orders add async, normal entity framework addition, save changes, and we return the new order. The order input is a class that is defined this way. So it is a derivation of the actual order, of course, but without the ID. So we only define the things that we need as input. And then, of course, the next step is once we have the mutation, we have the input defined. The next step is defining the, let's say, the object types for GraphQL to understand how to map them, how to use them. So we start with the input. In case of an input, if you see, let's say we see our product type, we were deriving from type object type. But inputs are a special type, and they are of type input object. So when we define the types for an input object, we should always define from the type input object type. The rest of the syntax is more or less the same. We say which business object to use, let's say, for the derivation. We can give it a name. We define the fields. We give the types that it should use. So for line items, we have a list of line item input types. Same, the line item input type is also similar, derived from input object type. We have the input. We define the fields. We try to, again, rename it for the naming purposes, and we define the types. And the mutation type, that doesn't derive from input object. The mutation type is like just another object type, so that derives from object type, so nothing changes there. Very similar to a query descriptor object. We do the, let's say we have the function that will do the job for us. We have the type. What we can additionally do in terms of flexibility here is define the argument. So say that this is the name of our argument that is there. And we also say that the argument is mapped to this GraphQL type. So we created the input object type called create order input type that we saw here. And now in our mutation, we map that to our argument. So what if we see this working? Building. All right, so this is on localhost 5031. I will fire up this. We see immediately the schema, and in the schema we see the clear distinction that we have query types and we have a mutation. And we can still walk through the schema for a mutation the same way as we were doing for query. So if we expand this, we see the create order expects a create order input. So as a client, I can always dig into this create order input. What do I need? I need these fields of these types. I can go to related fields to see what they require, and so on and so forth. And this should allow us to build our query. So when we did our query, we always used the term, let's say the keyword query to define our queries. But when we do mutations, we use a special term called mutation. That's a second possibility in the root element that we can do. And then within mutation, we see that we only see one item like create order. And if we do this, you see IntelliSense tells us we need to give an input and we need to do stuff. So I'm going to quickly copy paste my pad. Some formatting error, but yeah. So we have an order. So out of a certain place, maybe this time it was John Watson who orders from the same address, and he orders this of 2 times and this maybe 6 times. And if we look at the database for our orders, I can run the query again. So far, all my orders are from Mr. Sherlock Holmes. And this time, John Watson, he puts in an order. And what we are trying to, what we can also see here is, as part of this mutation, we can also request data back. And there also, as GraphQL allows us, we have total flexibility on what kind of data we ask back. So for example, so my last order was order number 6. So if we create this order now, so we asked for just the order number, and we got back, okay, order number was order number 7. If we go to our database, execute this, we have order 7 from John Watson available. So to show the flexibility that this can do more, we can, let's say, we ask for another field because maybe our client needs that information once an order is submitted. And we submit another order, and you see GraphQL is able to carry out that creation or that mutation and still be able to give us back information that we request for that newly created item. And again, exactly what we requested for, nothing more, nothing less. So that was mutation. And then from an application standpoint, we start asking ourselves, okay, but we did a create, we did a query, we did let's say an update or a create, but what other capabilities is on offer? And we can quickly try to look at, so what GraphQL can do is or HotChocolate allows you to use cursor-based paging. So if you are using really modern UIs with infinite scrolling, that's typically what you require. And it's very easy in HotChocolate to, let's say, introduce this kind of paging. So for example, we go for our product API again, and we go to our query type. And let's say we have get products. Something as simple as this, use paging. If we do this and then go on to run my GraphQL server again, running, I go back to my products and I refresh it and I try to look at my schema. Refresh. So this time you see we get a different, so we get back page info, we get back edges, and we get back nodes. And within nodes is where we get back our products. but we also get page info with has next page, has previous page, the start cursor, the end cursor, and that kind of information. So what if we now try to do a query based on this? Close this. Maybe. Always formatting is okay. So we execute this query now. And what we will see here is that we get back list of products, we get back the edges, and with every edge we get the cursor for the next item, and we get the page info. So the start cursor, the end cursor, if it has a next page, has a previous page. So really easy for your client to really implement, let's say, scrolling or infinite scrolling. You can also do something like this. We can say, give me back only the first one. And then we see that this changes. So we get the first one. So we got only one edge. But then if you see here, this already, because we had 3 items, it has a next page now. And it has no previous page. But we can now use the cursor, for example, to, let's say, get back the next item. So we can say after, and this, execute this, and then we have the second item, and then we have a different cursor, but now we see that there is a next page and there is a previous page. So paging through your queries is made quite simple with HotChocolate. We can do quite some filtering with this as well. So we try to do a quick look at filtering. So what we need for filtering is the package hotchocolate.data. I'm going to quickly add that. And then in here, again, very simple, maybe on the next line, use filtering. How not surprising at all. So we do filtering and we go with that run. Running back to our initial query, reload the schema, waiting for it. Yep, reloaded, and let's see what we can do in a filtering. Let's say we want all products that are of color black. So we start writing our filter where, and we say color. So that's one of the properties. And we say contains, let's say black. I'm not sure. Schema. Two products. One moment. Why is this? So where color contains black, I think we added it. Oh yeah, I know what I did wrong. So we missed out one little thing in the startup. What we have to do is in the GraphQL server, we have to say that filtering. That's what I was missing. So run. And back here, refresh the schema. The squiggle is gone. And if we now execute our query, we see that out of the 3, we get back only the 2 products which are of color black. So you also have immense filtering capabilities when you are, let's say, querying against your GraphQL server. After filtering and looking at filtering, paging, and some of this stuff, security is important. So how do we work with security in GraphQL? The Hot Chocolate implementation inherently uses the .NET authorization modules, but it also implements it in a GraphQL way for use when you are implementing your server. So we, of course, need a package. It's called the Hot Chocolate ASP.NET Core Authorization Package. So we add that. Okay, we go back to our query type. Maybe make it a little bit simple, remove the paging and stuff, and then we say, yeah, how difficult, authorize. So we say this operation, get products, needs an authorized, an authenticated and authorized user. So if we look at the overloads, we can use .NET Core policy-based authorization. We can use just normal role-based, and of course in empty, when it's empty, like any the authorized attribute from .NET Core, this works just that it needs an authenticated user. And this time, not to forget, we also here say add authorization. And we go to run. It's running, and we no longer need this. We can refresh. We are back to the old one, and in this case, let's say we are asking for the name and the SKU of the product. And what do we get? The current user is not authorized, so it's looking if the user is authenticated. So that's normal, but what if we take this a level deeper? What GraphQL allows you to do is also take this, so this was at an operation level, but we want to limit one field from an entire query for it to be required to be authorized. How can we do that? So let's say we move it from here and we go to our product type and say, oh, something like the SKU. You need certain roles. We don't have role definitions now, but at least you need authenticated and users with certain roles to be able to see this field. So we do it at the field level, and we go about running our project. We do a refresh of our schema, and the next time we run it, what do we see here? You will see our data is returned. We get back products, we get back the name, which is an open field, but we don't get back a SKU because this is the field that requires the authorization. So we of course get error messages that at this location for products, at SKU, we don't have an authenticated user. For role-based, you probably can do more meaningful messages, but it still allows our application to function, whereas giving granularity in terms of authentication and authorization that we can offer. So that was authorization. And I will move this to continue with our demo. Start up. Just keeping it simple for the rest of the evening. Okay. But now we are still left with let's say three different microservices, each being built also with a GraphQL endpoint. So we have like smaller, we have GraphQL endpoints, but they only serve a part of what we are trying to do as an application. But to me, as a client, it only makes sense when I'm able to, let's say, query product and its inventory together. And if you remember from the presentation of Donald, that we have the concept of gateways, and the gateway is where all of this comes together. So what we are gonna do is, let's say, I'm going to use some boilerplate code from a template that our friends at the Chili Cream platform they publish. So we create a gateway, we go into the gateway, and this. So the server creates it. So we look at the project. We have a whole set of boilerplate code that has been created for us to start up the program. The query, we go into the project. We can remove these default packages because we are going to need our own. The query, we don't need it at the gateway, as you will soon see, so we will remove that as well. And now we go on to add our packages as necessary. So we first, of course, add the Hot Chocolate ASP.NET Core package. And then for the gateway, we need another package, that's the HotChocolate.stitching. And this is where the magic happens, where the gateway is able to, let's say, look at all the downstream services, get their schemas, put them together, and then we, as a client, we connect to the gateway and see that one unified, let's say, the endpoint. So we added our packages, and the cool part about the gateway is, yeah, you hardly need to write any code for the gateway, as we will see. So we don't have any query type, we don't have any business objects, nothing. What do? We first start with creating HTTP clients towards our downstream APIs, which are running at this location, 5011, 5021, and 5031, all of these. And then we need to tell our GraphQL server that how should it work as a gateway and how should it get all the formatting, but let's say yeah, this is also not. We say services, add GraphQL server, standard step. The thing to note here is this this extension, add remote schema, and we are passing a name type of the HTTP client, so products, inventory, and order. Yes, and that's it. Now our gateway knows that when we start the gateway, it has to go to these URLs, get the schema, and put it all together into one. So what I will try to add here is a quick start projects. Just doing some quick work to ease out. So all this PowerShell does is it's using Windows Terminal. It's starting all my downstream services and starting my gateway. So that's all it does. So I can quickly on this. I can bring up Okay, my product service is running, my inventory is running, my order is running, and so is my gateway. And my gateway is at HTTPS 5001. So I can simply do this now. Refresh. Okay, if we take a quick look at the schema, you'll see I'm running my gateway at 5001, and you see the gateway has seamlessly brought in all those. So this is from product, the two product queries, the inventories from the inventory API, the orders from orders, and also the mutation from orders. It has brought it all together into one. Yeah, and then if we now sort of do the product query in here, products name SKU, we are still executing the same query that we were executing against the product API. And yeah, it still gives us back the data. There, you can do a little bit more. So what if we want to combine the product and the inventory information for that product together? What we need to do then is I will stop my gateway, or I'll just stop everything. For now, I go into my gateway and do something quick. So we are going to add a file called, and we called anything stitching.graphql. And in this, what we are will do is we will tell the gateway to do something extra. So what does it have to do? It says for type product, extend it runtime on the fly. Add a new field there called inventory, which returns a list of inventories. But how does GraphQL know how to get the data for it? So we say the delegate is that for this field, when this is asked, you need to go to the schema inventory or that service at this path and pass on the SKU from the product in question to, let's say, to get back the data. And then in startup, we just go on to this here. So add type extensions from file, a special extension again, and we give the name of the file. And if we now go here, start my projects again, they are running. And now maybe we just do one product just to check. I think. Well, what's that? What did I do? Oh, not sure what happened there. Oh, I didn't refresh my schema, maybe. No, 5. Okay. Name maybe. Oh, this is not working, but I can. So, yeah, essentially this is what we saw at the start in the earlier demo when we were querying for products, and yeah, bad luck for this demo. But for some reason, I probably made some mistake somewhere. I cannot get what's going wrong. yeah, maybe something with copy paste. It looks like a special character, but I can show you from another implementation, which we will share from which we have shared on GitHub. You can look at that. It works pretty much the same. And just quickly showing this. Come on. Yep. Running. It came up, and now we can also see that we have the inventory in here, and we can get the stock for this item as well in one query. So in essence, we asked for a product and inventory. The gateway knew that it had for inventory, it had to query the inventory API. It sent the part of the query there and the part of the rest of it to the product API, got back the responses, put it together, and give back one endpoint. So that was it. So from a server point, we had microservices. We converted them into GraphQL endpoints, and then eventually used the gateway to bring it all together, and did a little bit even more, let's say, to combine even entities together and do some smart routing in the gateway to do that. So yeah, that was it for me to show. And yeah, and Arjan has some also some cool stuff to show from the client side.
Yes, I have, Arin. Thank you very much. It was clear to me, but I don't know if it's clear for everyone. But I will continue to use the GraphQL gateway server for a client I made for the demo. Let me spin up the servers. Just see. In the meantime, let me explain what I'm going to do. I have created a Blazor client, and Blazor, well, it's a new kind of a new technology from Microsoft. Basically, it's the follow-up of web forms, ASP.NET. And with Blazor, you can create web clients, basically. And you have two types of two hosting models, I should say. One is you have Blazor server, and that is kind of like ASP.NET on the server side, on the web server side, and C# is running within the ASP.NET hosting environment. That is more similar to ASP.NET web forms in the past, or it is actually web forms is not over yet, but it's not in use. But it is still in use. But Blazor will become the the follow-up of it. And then you have, and that is more interesting, I think it's Blazor WebAssembly, and that is that the .NET C# runtime is running in the browser, in the WebAssembly container, and so you can use C# as of the similar way as you do it with JavaScript. So that is interesting. But for now, for the demo, I have used Blazor server, and it will communicate using Signal Air. It's just a technology. It's basically HTTP, but using WebSockets. This is not relevant for this demo, but maybe you can use it for your own benefits. You can see here now that the APIs are all running. The APIs Arin created and explained. So you can see here the gateway API, and that is the API the client is communicating with. So that is the single API we have to deal with. I'm having here my Blazor server solution. So you can see here, this is just created from the template, from the Blazor server template within Visual Studio. And you can create the Blazor server client, and to use the GraphQL server, or to talk to the GraphQL server, it is I'm using the Strawberry Shake client library. It's also from Chili Cream, and for that you need to do some steps. It's all documented on the website of Chili Cream. I can show it. There are some steps you have to make to create a GraphQL client. The GraphQL client is written in C# also, but you can have also other implementations for other platforms for creating a GraphQL client. You can create a GraphQL client for Python, for Java and JavaScript, of course. But this is the Strawberry Shake C# GraphQL client. It's a mouthful, but let me see. Oh, just a moment. So you need to have to install the .NET tool, Strawberry Shake tools, and this is needed for to create or to generate the C# code based on the schema we are going to download from the GraphQL server. Just a tool to install. Apart from that, you need to install some packages. You can do that using the package manager of Visual Studio itself or Visual Studio Code. You can do it on the command line or CLI. Make sure you have the latest versions, because Strawberry Shake, well, it's kind of like in preview at the moment, and they are working on it, so it's work in progress. So I made the mistake to have not the latest version, and well, you get in a lot of trouble. So when you have installed those tools and packages, then it's time to get the schema from the server, and you can do that also from the command line, and you use the URL, the endpoint of the GraphQL gateway. So this is the gateway URL you're using. And if you are doing that, you get the complete schema from the server, just as you do it in, let me show it, in banana cake pop. You have the schema here. So you have the meta information, basically, of the data, and you can see the schema here, and you have the exact schema also here within my client, and the schema is the basis, will be the basis of my code that will be generated automatically. So once I have the schema downloaded, the next step is that I, in my queries.graphql, I define my GraphQL queries. You can see some examples here of get products. To get the products, we have a mutation for add order, and it will use this definition, these queries and mutations, to automatically generate the code for me. Now that is very convenient, I think, because you don't have to do it yourself. It will be generated by the strawberry cake shake, I must say, library. So every time you do a build, I don't know if you can see it, but if you build the solution, well, something must be changed then, of course. I don't know if it's... You can see there is well, just a moment. You can see there is some code generation going on, and the code generator of the strawberry shake library creates a directory generated, and it will create a C# classes, I must say. So this is generated code. So you can see there's a lot of code there for just a few queries, but I assume it's needed. So it will build a strong typed representation or presentation of your schema, actually of the queries you created here. Nothing more, nothing less. So the queries we defined here, the definitions, it will take that and it will generate C# code of that, which you can use in your application. So for example, if I go to my product list, the product list is just a list of the products, of course. Then you can see here that, well, just a moment, I'm going to the product service. I'm using here an interface API client, and the API client is coming from the generated code. So if I go, you can see here that I'm now in the generated code. You can see that the API client is here and has two properties: get products and add order, and those correspond to my queries I entered here in my query definition. So that is how it worked. It's very easy to generate the code. So if I, for example, you can see it if I add a query here. Well, there's some. So what I do here is I create a query, get orders, to get all my orders. And I want to return a fragment of the order fields. A fragment is just an artifact of the GraphQL query language to enable me to get a reusable set of fields again and again. So the fragment can be used everywhere in other queries for in the order context, of course. So it's a convenience thing to get reusable building blocks. But anyway, here I have the order, the get order, and so now if I rebuild my solution, takes a while. So now I expect that the get orders is generated also. So you can see here that get orders is the new candidate here, new property, and all the logic concerned with this get order query is also in the generated code somewhere. So you can see if you add a query here, or a mutation, or another thing, and the rebuilding makes sure that all the items here are generated for you in the C# class. So if I go to the well, I've used the service pattern here, and well, Blazor is part of .NET Core and also supports dependency injection. So I get, if I go to the startup, you can see that that I register here my GraphQL client, my generated GraphQL client as a service. So that means that I can use the API client, the interface. I can use that with the dependency injection functionality. And for services, it uses constructor dependency injection. But I can also use it in my. I can also use it if I have an example of it. No, not here. Where is it? Oh yeah, I can use it also in the code behind classes of the Razor components. So if you are a little bit familiar with Blazor, then you have Blazor, you can make your own components, just like in React or in Angular. And they have the extension .razor. So this is a component. You can see the Razor style syntax mixed in with HTML and CSS. And the code behind is the actual code, in this case C#. You can compare it with just HTML and CSS and JavaScript all together, but this is a more, I think, a more structured way to set up components. But in this way, you can inject services or classes, so to speak, with the inject attribute, and so they get instantiated automatically for you by the dependency injection manager. So you can see that here is the client setup, and we are pointing to the GraphQL gateway endpoint. So the client knows how the gateway is accessed. Normally you have this in some configuration file, but for this case I just put it in here. And you can also see here some services needed to handle the data properly, and using a dependency injection mechanism. So that's how to set up the client. If I go to the, well, I can just run it to see if it's working. Just a moment. So you can see here that you can see the product list here. Well, we have 3 products in the database, in the underlying database of the product API. And as you also can see here, that there is stock information for each product. There is stock information. So if we go back to the query, just like the query Arin showed, you can see that the get products gets all the product information plus inventory information, because that is stitched together with the product type. And so on the client side, we have we can access stock information via a product. So that is quite handy from a client perspective. So just to say, well, we want stock and we get stock. And how does this end up in the C# code eventually? Well, here we have the code behind of the product list, and you see, well, we do get we call here the get products of the product service, and the product service is going to the interface, of course. But the implementation of that interface, it's using the API client, and we get the get products method available there. And the get products comes from the generated code again. So if we go to the get products, we have here the entry point for the interface, and this method will access the get products or the GraphQL query get products to retrieve the relevant data for that product. And we do some mapping here to shape the data So it's appropriate for our view. So it will be rendered correctly. We use a product model. It's basically a view model that is built to create a specific shape for our view, the product list in this case. So that is how this data comes to the client. And well, we can see that we can see that here the stock is, for example, the stock is low here. That we can do that because we have access to the stock information. You can see here. So the stock information comes from the inventory object, which is stitched together with the product. And if we look at the product card, we can see that we can just use C# here together with HTML, just by prefixing an ampersand here. So if the stock is lower than the threshold, and the threshold is just an imaginary number, but makes no difference. Then we say, well, we are low on stock, else, well, we have enough stock. That is a very simple rule to display this information. So if we add some products to our cart here, you can see that well, we have a cart, and well, to demonstrate how we can create an order from this, we actually use the query, the mutation query, to add an order. This is the query we do, or mutation, I must say, to add an order. We just saw it also in the demo of Arin. And using this function to create our order, and the input, well, it will be provided by our client. So if we can see the C# code again, eventually this method is responsible for saving an order, and the data is coming in via the order model view model, and there's a mapping. You can see here the create order input. We also saw that in the previous demo, and we filled that input with our data, and we are calling the add order function that resides in the generated code. And hopefully we don't get any errors here. So that is what is happening. So if, I need to fill in, because those fields are required. Let's drive. I have to fill in some. It's a familiar address. This one is. And then we create an order. So now the order is created. We want to show the orders we have made, but you can see that we have no orders here because we have no code to get the orders. So let's see why we don't get any orders. So I guess we go to the order service, and to see that the get orders, well, it doesn't have any code in it. But no worries, I have some code here that we can use. Basically the same structure. So again, we are using the API client, and we can use the get orders because it's generated again. It corresponds to this get orders query. And we do some data shaping again to put the data in our model. No, this is the wrong. Where it is? This one. To put the data in the order model, and then we can render it in the client on the page. So building. It takes a bit longer to build because, well, the code has to be generated. There is some smart mechanism that if you don't change the query definitions, then it won't generate. But once in a while, it generates while the query definition file is not changed. I don't know why that is, but well, perhaps it will be solved in the future. So now I have my order data with my products I ordered in the past. So that is basically, in a nutshell, how you can build a client, in this case a Blazor client, together with the strawberry shake library. And well, the advantage of the library is that it generates code for you in a strong type manner, of course. And you can easily extend your queries here, or add queries or mutations and whatever you need in your client. And it will generate the classes for you, and you can use them directly in your code. So that is very nice, and it is also a very quick way to set up a client using GraphQL, and you don't have the complexity of REST APIs or multiple REST APIs in your client. You have just one endpoint where you can consume all your data that is needed, and you have also the flexibility to get the fields and the collections you want instantly. So it will make you more productive, I think. And you can also use the microservice in the backend. The GraphQL gateway server can be quite complex, but all the complexity you don't have on the client. So that is well, I like.
Thanks, Arin, for that.
Okay.
So can we over to the Q&A? So thanks, everyone. You made it till the end. Highly appreciated that you took the liberty to watch the introduction and also all the coding demos of Arin and Ian. So I already saw some questions that probably Sjoukje will bring up. But if you want to reach out, please reach out to any of those handles that are on the screen at the moment. The first question I can already answer, is the source code available? Yes. Arin uploaded all the source code and demos at GitHub, which is available at this URL. And this also includes the Razor demo that Ian provided. So feel free and start hacking tonight. Over to you, Sjoukje, because I think there are some questions.
Yeah, we have a couple of questions. Yeah, shall we remove the screen sharing for now? Yeah. The first question is from David Jansen. Is GraphQL always these solutions, or are there situations where you would still prefer the REST approach?
Who dares to answer that?
Go ahead.
Go ahead.
The REST APIs is typically useful between downstream APIs, and where you have a fixed contract between different web services, where you have where versioning is important, and static negotiation is important, and so there is REST is there still the best thing to use. But for GraphQL is typically I think a client thing. So in this case, this use case is a good example where we have the web client using GraphQL and targeting a single endpoint. So that is. But I don't think GraphQL is necessarily good for system between system APIs or system web services at the back end.
No, that sounds logical. Yeah.
So if I would summarize, Ian, system to system API calls, that's probably where REST will stay.
Yeah.
But let's say if you need to have a more optimized API serving different types of clients, then GraphQL API is maybe the best solution.
Yeah, and maybe to add, if you're looking at composable applications, so where you also have your own set of APIs, but you also have like packaged solutions that you bring into your solutions, GraphQL with the gateway can really give you an edge there to bring it all together for your clients. So that's also where GraphQL really adds benefit.
Yeah, I can imagine that. Is it also because it looks like you have a lot of manual configuration and coding that you have to do to set up your gateway and your services? Is it also possible to automate that?
So there is some automation in the what Arin showed to create the gateway automatically. Yeah. But based on existing REST APIs, for example.
Yeah.
So, but if you need to create a GraphQL server from scratch, well, that can be quite cumbersome, maybe, or quite complicated. But if you do it by hand, well, yeah.
Okay.
Could be a lot of work.
Yeah. Yeah, but if that's the thing, the way to go to combine multiple services and integrate them, yeah, it is a good solution. Yeah.
But the templates provide you that guidance, so the templates that Arin showed you, all right, gives you a lot of that plumbing already. So yes, from scratch it's a lot of work, but by the use of the templates, I think what Arin also showed, it's not too much of a hassle.
Yeah, so the groundwork, it's really, so if you're starting from existing infrastructure, there you sort of already have your business logic in place. What you're doing is as simple as mostly you first need to think about your schema, and then you say, okay, what do I expose? So it's as good as writing a controller from a REST API perspective. So you could still reuse all of that logic. and you still do it, or even when you can put a GraphQL endpoint in front of a REST API. So you could even just have that as a layer in between. So there are multiple ways to do it. You could really do it smart, and the gateway is like really, like I showed, it requires very little coding because you just need to tell it where the schema lies, and it's smart enough to put that together and expose it. So
yeah, very powerful. We have one more question from the chat from Descol Dragon. Can GraphQL be seen as a platform to create composite services on top of granular services and expose those in a handy fashion?
Yes, absolutely. I think that is the, let's say, the power of GraphQL, right? Typically, what you have with microservices, that they are so small, fine-grained microservices that they only service a very small of the data needs that a client needs. And as a result, you need to have these, many API connections from the client to fetch all the data that you need. And GraphQL really gives you that single API endpoint from a client perspective to fetch all the data that maybe one or multiple screens need in a single request. I think also what Arin mentioned, if you're using, let's say, some of these headless architectures these days for, let's say, your e-commerce solution or CMS solution, you typically want to combine that with data from your own on-premises systems, right? So maybe you have whatever product data in a headless commerce solution, or maybe you have CMS data in a headless CMS, but you want to combine that with inventory data, which sits, in your on-premises backend systems. These headless systems already come with a GraphQL endpoint, and you can very easily stitch them together with your own, backend services, providing a single schema, single API endpoint to fetch the data both from the headless solution as from your on-premises system. So.
Yeah, great. So I think that are all the questions for now. So thank you for this very great session with all the cool demos. Yeah, very interesting stuff. Thanks a lot. And for everyone who missed the first part, we posted the link in the chat so you can watch that one as well. So thanks a lot. And this concludes this edition of the Build Tech Talks. And this evening session and all the future sessions will be posted on our YouTube channel as well, of course. And if you're interested in more of this, please sign up to our YouTube channel or our Twitch channel. And you can also sign up to our Capgemini digital meetup page. So you get updated with all the future sessions that we are planning. So our next Tech Talk is going to be an IoT workshop, and it will be taking place at May 6th. So hope to see you there. Thanks for watching, and see you next time. Bye-bye.
Thank you. Thank you.